Yeah, so I think now things should be fine, right? Okay, great. Let's start now. Yeah. So those who are listening me first time, I'm Sachin and I'm co-founder and instructor at goclasses, right? And yeah, so I have done my masters from IISc, and after IISc I have went to Amazon and I worked there as an applied scientist. I also got All India Rank 33 to get admission into IISc. Okay. And if you have any doubt, then you can definitely join our Telegram group. This is the link. Link will also be found in the description. Similarly, if you want to join test series, then you can definitely join test series using this link. You can also find this link in the description. Okay. So today we are going to start or we are going to solve few problems using in the sorting. So mainly we will be just dealing with the divide and conquer mechanism, which are quick sort and merge sort. So we will be just dealing with quick sort and merge sort in this particular video, because this session is not be taking too long. Like, we are just conducting small sessions to help you out for the revision and for the practice purpose. So we will be solving quick sort and merge sort questions. Okay. And since these two both are divide and conquer techniques, so I will also tell you some divide and conquer general ideas. So let's just start. So in divide and conquer, what do we have? We have a big problem. We divide that into a small problem, and then we further divide that into smaller problems, right? That's what we do in divide and conquer. Like, for example, like let's suppose these are the two. Okay, one second. Let's just go to the next example. So suppose that you want to eat some apple, and that apple is too big. Then what you will do? You will definitely divide that apple into two halves. And suppose that still it is too big to eat, then what you will do? You will definitely divide that into further halves. So that's how you do in your daily practice. I mean, you have some apple to eat, let's suppose, then you will divide, because that cannot fit into your mouth, right? Directly. So you divide into two half, then you divide it further into two half, and that's how you eat the apple. So basically, dividing is just cutting, and then eating is just conquering it. So basically, it is called divide on conquer method. And the analysis, if you want to do the analysis, so what you need to do, you need to see that how much time. So what we are doing here, we are dividing. So you need to see that how much time you are taking to divide, and you need to check that how much time you are basically taking to solve each sub problem. Let's suppose that you have a problem of size n. Then let's suppose you are dividing that into n by 2 n by 2. Then you will say Tn, which is time complexity to solve this problem of size n, is basically time complexity to solve these two problems of size n by 2 plus time to divide plus time to combine. So this is general idea in divide and conquer, which means that you will be solving your sub problem, you will be adding the time to divide, and then let's suppose these sub problems are solved, then you will be adding time to combine also. Okay. So since we are particularly dealing with quick sort and merge sort in this particular video in the sorting mechanism, then here I will talk about this time to divide and time to combine. Here let me write time to divide in quick sort and time to combine in quick sort. Similarly in merge sort, time to combine. Now quick sort says that if you want to divide, then it will take theta of n if you just want to divide. And merge sort says that if you want to divide, then it will not take anything. I mean, it will just take a constant time if you want to divide. Okay. If you want to combine, then quick sort says that in combine you are not going to incur any cost, but merge sort says that in combine you are going to incur some theta of n. So these are different time to divide and combine in quick sort and merge sort. Okay. So you might recall it, like in quick sort, the time to divide in basically divide, you use something called as partition method. And here, if you want to combine, then you use something called as merge method. Okay. Great. Now let's just see some of the questions, and before that let me maybe give you some some theory behind the merge sort and quick sort. So let's just talk about this merge sort theory, and then we will go to the questions. So let me quickly revise this merge sort theory for you. So suppose these are the few numbers that you want to sort. As you can see that this is the confused version of you, I mean how to sort, that's what you are looking for. Okay, and then what to do? You will divide your array in merge sort. You divide your array into two halves. You recursively sort each half, and then you combine. So what you basically do, you have any array, you will divide your array into two halves, which means you will say that let me divide this array into two halves. And now interesting step is that you recursively sort these two array, which means you will say, let me say that like this array and this array are sorted, and then you combine. So these are the three steps. You divide, you recursively sort the first half and second half, and then you combine. So for example, let's suppose this is the array that you have. You will be dividing that into two half, and then for example, for the sake of example, let's say that if you divide that into two half, then you will be getting this, right? You will be getting this. Now what you need to do, you need to recursively sort it. Okay, so whenever we have a recursion type of problem, then I will be assuming like it is very much similar to induction, if you know that induction from discrete mathematics. Otherwise that is okay. So basically in induction I say that let's assume that it is true for n equal to k or something like that, right? So similarly here, just to avoid the complexity, what we can do, we cannot we may not need to divide it further. We will assume that it can be done recursively, which means that, see, I can draw the complete tree, that is okay, but for now I'm just telling you one very good intuition to solve any recursion problem. So what you need to do here, let's just assume, okay, let's just assume that you can sort it. Okay, which means this problem and this problem, let's suppose that you can sort it. Then basically you divide it, and then if you can sort it, then you will be getting it something like this, right? You will be getting this thing, and then you need to combine it. Okay, so this is how we will be understanding the recursion questions. We will not draw, I mean we can draw, but we will not draw the complete tree. Okay, what we will do, we will draw just one level. We will draw just one level, draw one level, and let's suppose that these problems can be solved. Okay, let's suppose that these problems can be solved. Then this will be this and this will be this, right? And then you will say that now you combine. If you combine, you will be getting this as output. Okay, so you will get to know this as we progress further. If you are able to recall from, if you are goclasses student, then you must be able to recall from our previous lectures. So actually I have told you the ideas and the difference between the recursion and induction. So this is same as induction. So I have told you the similarities between recursion and induction. Anyway, if you are not familiar with the induction, that is perfectly fine. Let's not worry about this. Okay, now let me just recall you that how does this merge sort work. So what you need to do, you will take your array, you will divide this array into two halves. Let's suppose this is one half, this is one half. You will somehow recursively, okay, you will apply merge sort on this. Let's not worry about that how you are getting this sorted output. See, let's not worry about that how to sort this. Okay, for now let's not worry about how to sort this. Somehow let's suppose recursively you can do it, and then you are able to solve it like this. Okay, then we are interested in the whole procedure. So basically what I'm saying here, you will divide your array into two halves. This is one half, this is another half. Then what you will do, let's suppose that using merge sort you are able to sort it. Let's suppose using merge sort you are able to sort it. Then what you will do, now you will combine it, right? And you say that finally it is sorted. Now obviously the crucial step is that how this is working recursively, right? For that, you obviously, if you want to understand, then you need to make the whole tree. So let's just understand with the help of questions. Okay, so this is your merge sort algorithm that is look like. So again, this is a revision class where I will be revising the theory with quick notes, I will say. Okay, quick notes, I will be revising the theory quick notes, but mostly this is a practice class. So I will say that it is revision plus practice, but mostly it is a practice class where I will be more focused on the practice. Okay, so that's why I'm just quickly going through the theory. Anyway, so that's how the merge sort algorithm look like. So it says that like, let's suppose that you have two indices I and j. If you want to sort any array A, then initially I is 0 and j is n minus 1, which means from your main function, let's suppose int main, this is your main function, you will call this method something like this: merge sort a comma 0 comma n minus 1. From your main function you will call something like this, and then what it is doing, it is saying that let me go to the mid position, let me go to the mid. Okay, it is going to the mid. It is saying that let's do one thing, let's just pass this into I to mid, which means let's suppose this is initially I and this will be mid. So it is saying let's just sort this part recursively, and then let's just sort this part recursively. This is what it is saying. Let's just sort both of these parts recursively, okay, and then just combine it. So let's understand with the help of questions. So the time complexity is nlogn. You might be knowing it. So let's just first understand that how to combine, and then we will just go back to the merge sort, and then where we will see that how to even divide it. Okay. So suppose that till now you have not understood anything, which means you do not know what is a merge sort, you do not know anything. Let me pose a completely different problem, which means let's suppose you want to merge two arrays such that this is a sorted array, this is also a sorted array, and then finally you want to merge them, and then you finally want one sorted array, right? Which means, see, this merge sort algorithm is basically just relying upon this. If you know that how it is working, then you actually get to understand this merge sort. It says that you have two sorted arrays, one sorted array that is from I to mid, okay, another sorted array is from mid plus 1 to j. Suppose you have two sorted arrays, or one sorted array in which the indices are I to mid and mid plus 1 to j. Suppose you have one sorted array or two different sorted arrays, then if you want to merge them, then how you can merge it? Let's just see this quickly. So let's suppose these are the two sorted arrays, okay. Then what you will do, you will be comparing the first element, whichever is minimum, you will be keeping it at the first place, and then you will be incrementing the pointer based on that, right? So let me just go to this particular example. Let me just show you that how it is happening. So suppose you want to merge these two. First check whether these two are sorted or not. First check whether this one is sorted. Yes, this seems sorted. I mean, this is actually sorted. This is also sorted. So what you need to do, you need to just compare the first and first. Then you will take the minimum here 1 and then cross it out. Just compare 3 and 2, take the minimum here. Just compare 3 and 4, take the minimum here. Just compare 5 and 4, take the minimum here. Just compare 5 and 6, take the minimum here. Just compare 7 and 6, take the minimum here. And then just compare 7 and 8, take the minimum here, whichever is minimum 7, right? And now you notice one thing, that one of your array has been adjusted. Adjusted means all the elements you have copied to a new array. So whatever is left out, in this case there is only one element left out, you just copy it freely, okay? I mean, you just copy it freely. So whatever is left out. Now why I'm telling you all of this, even though it seems trivial to you, because I wanted to analyze some number of comparison and these kind of things which frequently get asked in gate. Now tell me, if you are writing this one here, how you are writing one here? You have compared 1 and 2, right? That's why you have written this one here. In fact, you have written all of these elements after some comparison, like one comparison you did here, one comparison like that. Have you done any comparison when you freely copying this 8? No, right? So all of this has one comparison. So if the size is n, now I have taken n minus 1 comparisons just to write all of this. Have I taken any comparison here? No, I have not taken any comparison, because it is 8. I can freely write it because one of the array got adjusted, right? Similarly, let's suppose if it is 10, 11, anything, I can freely write all of them, okay? I can write 8, 10, 11 freely, which means there will be n minus 3 comparisons. If the total size is n minus 3 comparisons till this point, but these 3 elements I am getting free. Free means I do not need to compare these 3 elements with anything, right? Okay, I hope you understood that what is happening here. Like if one of the arrays get adjusted, then all of the elements you can actually write freely, and for that you do not need any comparison. Okay, so suppose this is another example. Here let's just see how it is working. So you will be comparing how many elements are there? 1 2 3 4 5 6 7 8 9 10. So 1 2 3 4 5 6 7 8 9 and 10. Okay, so you will be comparing this 1 and 10. So after one comparison you will be writing this. You will be comparing 2 and 10. After one comparison you will be writing this. You will be comparing 3 and 10. After one comparison you will be writing this. Since one of the list got exhausted, that's why you can freely copy all of this. So this is just free copy. Free means like without any comparison, right? Without any comparison. So which means, now tell me how many comparisons you are taking here. If I ask you only about number of comparisons, can anyone tell me how many comparisons we are taking here? I think we are just taking 3 comparisons, because just to write one, I have compared 1 and 10. See, this was because I have compared 1 and 10. This was because I have compared 2 and 10. This was because I have compared 3 and 10. So number of comparisons here, I have just made 3. And after just 3 comparisons, I see that one of the list got exhausted and I can just copy another list, right? So number of comparisons is just 3, but the time complexity is obviously n, because I have to anyway copy all of them. See, number of comparisons and time complexity both are different. Time complexity is still n because I have copied all the elements. Since I have copied, then I am dealing with the n elements. That's why time complexity is still n. Okay. So let's just see this. Maybe you can tell me the number of comparisons and the time complexity. Time complexity will always be n. Let's just talk about the number of comparisons probably. Okay. So this is 1 2 3 4 5 and 5 10. 1 2 3 4 5 6 7 8 9 10. Okay. So this is 1 and 2 if you compare, then 1 will be coming. 2 and 2 if you compare, you can take any one of the 2, but for the stable sort, as you know from the merge procedure, prefer this left 2. Let's suppose this is 2a, this is 2b, so I will prefer this 2a. Okay, you can prefer this 2b if you want to, but we generally prefer this 2a. So this is 3 and 2, I think this is smaller, so you just write 2b. 3 and 3, I think this is smaller, let's say it is 3a. Okay, so you just write this 3a, if whatever is smaller, write it here. And then this 4 and 3, I think, let's suppose this is 3b, so I think this is smaller, so just write it here. This 4 and 7, I think 4 is smaller. This 5 and 7, I think 5 is smaller. So yes, now these 3 elements you are getting free. So number of comparisons is how much? Comparisons is equal to 1 2 3 4 5 6 7, right? 7, because for these elements only you are comparing, and rest of the elements you are getting free, right? Number of comparisons is 7 here. I hope you understood that how we are calculating the number of comparisons, right? So let's just finally maybe do 1 or 2 more questions, and then you will maybe probably understand the number of comparisons more clearly. So suppose that these are the 2 arrays you have, I think 1 2 3 4 5 6 7 1 8 9 10 11 12 13 14. So these are the 14 elements, 1 2 3 4 5 6 7 8 9 10 11 13 and 14. Now let's just see that how we are writing the elements here. So you compare 1 and 4, you will be writing 1. Then you compare 2 and 4, you will be writing 2. You compare 20 and 4, you will be writing 4. You compare 20 and 5, you will be writing 5. You compare 20 and 6, you will be writing 6. You compare 20 and 30, you will be writing 20. You compare 22 and 30, you will be writing 22. 25 and 30, you will be writing 25. You compare these two, you will be writing 30. You compare 40 and 33, I think you will be writing 33. You compare 40 and 35, you will be writing 35. You compare 40 and 50, I think you will be writing 40. Yeah, at last, so 45 and 50, you compare this 45. Now, at last, you just got one element which is free. So this is the worst case. I mean, in worst case, you have to fill all the elements and just the one element you are getting in the free, right? Only one element you are getting free. I hope you are understanding. So if you are not able to see my screen, maybe, okay. So maybe now you can probably watch it better. Okay. So at last we are just getting one element free, right? So number of comparisons are n minus 1, right? Okay. So that's great. Now let's just see this. Maybe you can do this later, okay, as an homework. So if I just ask you to solve this question, where they are saying that you are merging two sorted lists, one is having size m, one is having size n. They are asking number of comparisons. Number of comparisons, they are saying this order of m means, see, whenever you write order of n, what does this mean? Or whenever you write theta of n, I think that you know, it means equal to c into n, right? Let's just omit this c for now. Let's just say that it is equal to n. What does this mean? It means it is, this quantity, let's suppose you are writing fn or any function, okay, any function equal to order of n, it means that function is less than equal to n, right? Less than equal to n. So if they are asking in order, it means the number of comparisons are always less than equal to. Always less than equal to. Can you say the number of comparisons are always less than equal to m, or less than equal to n, or less than equal to m plus n, right? Yes, this is true. Reason being is that in worst case, even in the worst case, what you are going to do, even in the worst case, you are going to say that only one element you get at edge free, only one element you get edge free, and remaining all the elements you have to compare. So even in the worst case, this is the number of comparisons, which means the number of comparisons are at max m plus n minus 1. Are they lesser than equal to m plus n? Yes. So that is why C is the correct answer, right? Now let's just see this option, which is saying lesser than equal to m. No, need not to be. They can be 2m or something. If n is basically, let's suppose n could be anything, right? 3m. Then what if n is 3m? Then it is 3m minus 1, which is obviously greater than equal to m, right? Okay, maybe n is m square. Maybe let's suppose n is m square. N and m are independent. It could be anything. So in this case, you will say it is basically number of comparisons are, if n is m square, see, in worst case, number of comparisons are equal to m plus n minus 1, exactly equal to, okay, there is no asymptotic notation, this is exactly equal to. Now maybe n equal to m square, maybe it could be anything, right? These are independent, maybe m equal to n power 4 or anything, right? Or something like this. Then in this case, number of comparisons will be m plus m square minus 1, which is, or in this case it is n power 4 plus n minus 1. So it is almost same as like order of m square. It is in m square, it is in n power 4 or something like this, right? It is in n power 4. Then can you say that it is order of m or order of n? No. Can you say order of m plus n? Yes, because it is always m plus n minus 1. So this is order of m plus n. Whatever is the case, it is always order of m plus n. If n is m square, then yes, the whole value will be n square or n power 4 based on the values, right? So I hope that is fine to everyone. Okay. Now let's just get back to this merge sort, and this is very nice looking algorithm that we have. So what we do in merge sort, we basically have two phases in any recursion. Okay, in any recursion we have two phases. Let me probably write here, in any, okay, any recursive algorithm, there are two phases. One is like calling recursive function, which let me just call it forward phase. Another one is when recursive function returning of recursive functions. Okay, let's call it backward phase. Which means in any recursive algorithm, you draw a tree. Let's suppose this is merge sort or anything. You will say, okay, let's suppose it is from I to j. Then you will say it is from I to mid. You will draw a tree, right? So merge sort I mid plus 1 to j or something like this, right? And then you grow this tree. Then you will say it is a forward phase. Whenever you are growing this tree, it is a forward phase. Okay. And then when you started returning, then you will say, okay, this is getting returned, then you will say this is backward phase. If you start returning, then this is not a standard terminology, but just for the sake of understanding, I am saying this is a backward phase. Okay, so this is what it is happening here. Like you are dividing, and then you started combining, and that's how you sort it out. I hope everyone can recall this now, right? Okay, let's just do this question. This question I have taken from one standard university, and let's just see what it is saying. Like this will clear some of the things of the merge sort. It is saying that consider the array element in figure A. Okay, so this is the figure A element that you have. Then we have passed this array to a merge sort algorithm, and in between the sorting we observe that the array has been changed to figure B. मतलब let's suppose here we have 100 elements. ठीक है, this is the first element. This means that this element, let's suppose, could be 50. This element is a smaller element, let's suppose 2. This element is, let's suppose, 48, something like this. I mean, the bar tell you that whatever the number is, right? So let's suppose these are the total 100 elements, and obviously like here also you have 100 elements. They are saying that you have some numbers, okay, which are arranged very randomly, and then you pass it to merge sort, then you got this as an array in between. Okay, what do I mean to say in between? See, you have 100 elements, right? So you will call it from 0 to 100. You will call this merge sort. Then you will say that this is from merge sort. You will call this from 0 to 50, and then you will call this merge sort from 51 to 100. Then similarly, like you will call from here a merge sort which is 0 to maybe 25. You will call it from merge sort 26 to 50. You will call this merge sort 51 to, let's suppose, 75, and merge sort 76 to 100, something like this. Which means first you will be calling this will call this will call this. The calling sequence is like this. Let's suppose this is the function called C1, then it will call C2, it will call C3. Okay, and then maybe I am checking my array. See, let's suppose if I check my array at this point, which means after C1 it has called this, and if I am checking at this point, it means I have already sorted for 0 to 25. See, what do I mean to say? Let's suppose that this is the merge sort algorithm that you have, right? Now, if I ask you that how does your array look like at this point in time, you will say whatever was your initial array, it will look same. Let's take one initial array. Let's suppose your initial array is this. Okay. So let's suppose your initial array is this, right? Now tell me at this moment, how does your initial array look like? It will look like exactly same. Now tell me at this moment, which means at this moment, if I ask you how does your initial array look like, you will say you must have sorted. If mid is, let's suppose mid is I plus j by 2, which is 0 1 2 3 4 5 6 by 2, which is 3, with 0 1 2 3. So suppose this is till mid. Okay, you will say if you're asking me here, then I must have sorted the first half, which means my array will look like this: 1 3 4 20. And what about the next half? Next half, let's suppose it to start with, this is 6 5 7. Okay, just to start with 6 5 7. So the next half will be same, which is 6 5 7. You're getting my point? Which means if I just ask you that how does your array look like here, maybe if I just print my array, okay, if I just printf, if I just do a printf here, printf the array, then it will look like this. If I do a printf at this point, then it will look like this. It will say that I must have sorted the first half, and then now the second half is remaining to sort, right? If I ask you that how does your array look like at this point, you're getting my point? I hope you are understanding. If I ask you that how does your array look like at this point, you will say I must have sorted. See, if I just ask you, can you just printf? Pf means printf. Let's suppose array. Okay, just a pseudo code I am writing. If you just print, okay, at this point, then you will say your array will look like this. You must have sorted the first half, 1 3 4 20. You must have sorted the second half also, which is 5 6 7, and then you have not combined till this point, which means these two subarrays are left to combine, right? And then if I just ask you that how does it look like at this point in time, then you will say that at this point in time you must have combined also, right? You must have combined also. See, I hope you are getting my point, right? So at this point in time you will say you must have combined also, you must have merged also, which means now it will look like this: 3 4 5 6 7 and then 20, right? At this point in time it will look like this, which means now it is completely sorted. So earlier see, like you started with this point, you started with here. If I ask you let me maybe give you more clear picture. You started with here, I mean this was the, let's suppose, initial array that looks like. Now if I ask you that if you do just a printf at this point in time, if you do just a printf here, printf a, printf this array, then it will look like this, right? There is no change that you have done. Now if I ask you, can you do a printf at this point, then you will say yes, then it means you must have sorted the first half, right? And then similarly, if you ask me that how does your array look like at this point, then it means you must have sorted the first half is done, second half is done, and then you are just left with the comment. First half is sorted, you see 1 3 4 20 sorted, but the whole array is not sorted. Second half is also sorted, but the whole array is not sorted. Now I ask you that can you tell me how does it look like at this point, then you will say yes, now it is completely sorted, right? That's how, like, you can understand this algorithm very intuitively, that what it is doing at every step. So that's what has been asked in the question also. So they are saying in this question that this is some random like arrangement that you have. Can you get something like this? So what they are saying, so suppose these are the 100 elements. Now these are the first half, right? So this is the first half that you have here. So they are saying that can you have something like this? Tell me, can you have something like this? Then my answer is yes, I can have something like this. Let me tell you how. See, it means what? You must have sorted this first half, right? The first half is done, and then I think this is also sorted, and I think this is also sorted. So this is first half. First half is completely done. In the second half, like these two halves are sorted, like this quarter is sorted, right? So which means you must have called this merge sort, right? Which is from 0 to 100. That will call merge sort from 0 to 50 and merge sort from 51 to 100, right? 51 to 100. And then finally you call a merge procedure, which will merge both of the outputs, something like this you will be doing. Now if this is sorted, which means you are already here, right? You are here, you are at least here. I mean, you have done this, you have already done this, right? Now they are saying you have sorted this also, like half of this also, which means from maybe 51 to 75 also you have done. It will call 51 to 75 and then merge sort 76 to 100, and then it will say merge. Now can you tell me at which point you are currently? See, you have done this first half, you have done this 51 to 75 also. Let's suppose this is 51, this is 75, this is 100. You have done this because you have sorted this, right? You have sorted this also, right? You have sorted 75 to 100 also, but you have not merged it, which means you have not merged from like this second half, which means you must be at this point in time in your current execution. You must be here, you must be somewhere here, which means you must have done this, you must have written from this, you must have written from this just before I merge these two, this and this, just before I merge these two, I'm printing it, right? I'm printing my array and it looks like this. If I just do printf at this point in time, it looks like this. Is this fine to you? So everyone, like currently I'm not seeing any chat. Everyone who has joined, can you please confirm me if that is okay to everyone? Let me know if you have understood this point. What I want to convey is that how does your merge sort is working at every point in time. You should be understanding it very abstract way. Okay. Let me know if that is fine, or should I tell you something again? Maybe I'm assuming that that is fine, right? Okay. Now if you have understood this, then your merge sort should be easy to you. Okay. So there is also something called as iterative merge sort, which basically does what? It pairwise merge elements. Which means it will merge these two. That's called iterative merge sort. Okay. So let's see that how it is working. You will be merging these two. It will get merged into 210, and then you will be merging these two. It will get merged into this 35. You will be merging these two. You will be merging these two. That's how you can merge. And then what you will do? Then you will merge these two. Then you will merge these two, and then finally you will be merging these two. So basically, iterative merge sort goes bottom up way, which means like there is no split here. There is only combine, which means you are combining this 10 to and something like this, right? So how does it work? Let me just tell you. Suppose you want to merge these two, then see, the array is just one, which is this one, right? If you want to merge these two and these two, then after this phase, your array will look something like this. Your array will say this is 2, 10, 3, 5, and then 7, 13, and then 1 and 6, right? Your array will look like this. Now tell me, is this happening in parallel? Like, are you merging in parallel or something? Are these operations happening in parallel? I mean, how we are performing these operations? Are these happening parallel? I don't think so. Like, I mean, how can you do it in parallel? You have just, I mean, there is just one program. There is no threading or multi-programming or that, like some sort of these tricks that you are applying. Yeah, that you might do it, but currently I'm not assuming that you are doing any multi-programming, right? So, but yeah, currently it is not having in parallel. So what you will do, you will first do this, okay, which means you will first merge these two, and then you will merge these two. It is step by step procedure. Then you merge these two, then you merge these two, okay. I mean, it looks like it is happening in parallel, but in reality you are merging like this, and then you are merging these two. Then you increment your loop count or something, you will merge these two. And we have also seen the implementation in the full complete course, but for now it is not important. That's why I'm not telling you that, okay. But yeah, it is not in parallel, like that's how you do, but that's the iterative procedure, okay. So basically, if you are merging these two, then there will be a for loop. Let me just tell you bit about the implementation wise, that how you can do it, because some students have some confusion. That's why I'm telling you some implementation details here. So you will be having a for loop which will run in this array, which will basically I to 0 to n, and every time you are incrementing, so this is I less than n, and maybe you will say that every time you are incrementing initially by 2, okay. So instead of I plus plus maybe every time you are incrementing I plus equal to I plus equal, instead of I plus equal to 1, maybe with some parameter, okay. Maybe let's suppose size or something. Basically initially you will be saying I equal to 0, and then I need to merge only these two, so I equal to 0, and then you will be merging these two, so I equal to 2 or something like this, right? And then you will be merging these two, so I equal to 4, and then you will be merging these two, so I equal to 6. But once this is done, then you will do this thing again. So this is just a merge procedure, right? You will do this thing again, this whole thing again. I mean, you need to do it again. So which means you will be putting this whole thing inside another for loop, okay. I mean, this the time complexity you can analyze, it is just nlogn in this case also, but the implementation wise it look like this. So there will be a for loop which will be doing a pairwise merge, but I need to do it again and again. That's why this will again be put in the for loop. That will say that okay, now this time it will say that maybe your size by which you are incrementing, this time this size will get incremented. It will be, you are not incrementing now by 2, maybe you will be incrementing by the 4 or something. Basically you are doing the same thing, that has to be kept in the again another for loop, okay. I mean, implementation wise it looks like this. We have seen this in complete course. If you want, you can revise your notes, but anyway, that's not required, okay. For at this point in time, you should be just able to understand that how it is happening. So let's just solve this question. What it is saying, if one uses straight two-way merge sort, see this iterative merge sort that I'm talking about, that is also known as, okay, Knuth was the great computer scientist, named this algorithm as straight two-way merge. Straight two-way merging, okay. So Knuth was a great computer scientist, and I think yeah, in 1974 or some year, I'm not 100% sure, a very long back, he has won the Turing Award also, and he's currently alive, and he is publishing his books currently. So he has named this as straight two-way merging. So that's what they are talking about. They are saying straight two-way merge sort, which means that it is the iterative merge sort. In the iterative merge sort, they are saying that if you do it for the 2 passes, so after 2 passes, how it will look like. So let's just see that how this array will look like after 2 passes. Okay. So One pass means this is, see, this for loop, inner for loop, this is called one pass. I mean, one execution of this outer for loop, it is called one pass, and then again you do the same thing, it is called second pass, and then again you do the same thing, it is called third pass, which means this will be just one pass, this will be one pass. So you will be merging these elements. So now it is just 20 47, and then it will be 15, sorry, it will be 8 15, and then it will be 4 9, it is 30 40, it is 12 17. So basically you need to understand that it is just one array. First of all, these are not multiple arrays, it is just one array in which it is happening. Second thing is that it is not happening in parallel. I mean, it might happen in parallel if you want to, but currently it is not in the parallel. So now you will be merging these two, and this you can write as it is. So if you merge these two, which means you can just use a merge procedure, you will write the minimum here, or maybe you can just write the sorted sequence directly. 8 15 20 47, it is 4 9 30 40, this is 12 17. So 8 15 20 47, 8 15 24 9 30 40. Yeah, I think a B is the correct answer, right? This was a very easy question, but I have taken this just to make sure that you understand this iterative algorithm also very well, right? Now we understood this merge sort, we understood iterative merge sort also. Great. Now let's solve few questions that deal with merging k sorted arrays into just one sorted array. Let's just see these kind of questions too. So in the questions, what will they say? They will say input, they will say you have k sorted arrays, okay. Notice here that there are k sorted, okay, sorted arrays, each of size, maybe some size, you can have any size, but let me say each of size n by k, okay. Output is only one sorted array of size n. This is a typical problem that they ask in GATE. Let's just deal with this kind of questions. So let's just see few methods that how you can merge or how you can sort n by k size or k sorted arrays, each of size n by k. So suppose that each size is n by k, n by k, n by k, n by k, n by k. Okay. So yeah, I hope you are getting what I mean to say, that there are k sorted arrays and each size is n by k. Let me write it here. So let's just take two more arrays which are n by k size. So there are k sorted arrays, each of size n by k. Now what you can do, I mean, finally you want one sorted array, this is of size n, this is of size n, right? This is what you want from these sorted arrays. So for example, this could be 1 1 10 15, this could be 2 3 7, this could be maybe 6 6 9 or something like this, right? 6 9 11, which means that this is sorted by itself, this is sorted by itself, this is sorted by itself, and so on. But if you put all of this together, which means, let's suppose if you put all of this together, right? Suppose that you put all of these numbers together, then you will be getting something like this: 1 10 15 2 3 7 6 9 11, and so on. Now tell me, if you put all of these together, are these sorted? Obviously all of these numbers together are not sorted, right? So that's what they're asking, that if you put, obviously they are not sorted. That's what they're asking, that how can you get one sorted array? Now let's just see few methods of this. So let's just see method 1. In method 1, what you can do, you can put all arrays side by side, and sort them, which means you can just put all arrays something like this, all arrays side by side, which means you can just put all of arrays something like this, which means you will be just putting them like in this way, like this is the first array, and then you put the second array side, and put the third array side by side, and then you just sort this whole complete array, right? How much time it will take? Since the number of elements are n and merge sort time complexity is nlogn, it will take nlogn, right? But obviously it should not be a good idea. Reason being is that, I mean, for any n random numbers I just take nlogn, then what's the benefit of these having the partially sorted? I mean, this is sorted, this is sorted, so I'm not taking this as an advantage, right? So that's why it is not a very good idea. Let's just see some other algorithm where we will be sorting these nyk subarrays each of k subarrays each of size n. So what we can do, maybe let's suppose that this is what you have. This is one array, second array, third array, fourth array, and so on. So what you will do, you will be just merging them step by step, which means that let's just see that how much time it's going to take. Which means what you can do, you can just merge these two, and since you know for the size m and n it takes order of m plus n, I mean it is linear in this, right? So if both of size are, just to merge, okay, I'm not sorting, I'm just merging. If both of size are nyk, just to merge and to get one array, you are going to incur 2 nyk cost, right? Just to get this one array, the size of this one array is 2 nyk, okay, size is equal to 2 nyk, and you will also take 2 nyk time just to merge these two. Now let's just do one thing. Now let's just merge this one with this one. See, I'm just merging step by step. Let's just call it method 2. Okay, I want to see if there is some improvement. If you merge these two, then you will be getting one array of 3 nyk size. Here the size is 3 nyk. You will be having 3 nyk size. Now how much time you will be taking or how much cost you will be incurring? You will also incur 3 nyk cost. See, here you have incurred 2 nyk, here you have incurred 3 nyk. This is the cost that you are incurring. It is not like you will only incur 3 nyk. You have already incurred 2 nyk cost. See, here you have already incurred 2 nyk cost. No one can deny this cost, right? No one can deny this cost. Now you are additionally incurring 3 nyk cost. Now if you merge these two, then you will be getting one array. Let me write here. You will be getting one array of size probably 4 nyk, right? So here the size of that array that you will be getting is 4 nyk, but here you will be you will be additionally incurring a cost of 4 nyk. So which means you are incurring 2 nyk cost here. It's not like that you only incur 4 nyk. No, you already incurred this one and this one. So the total cost that you are going to incur is 2 nyk plus 3 nyk plus 4 nyk. Similarly, finally, maybe you will be having these are the till 4 you have 4 nyk, right? And these are the k arrays, so you will be having k nyk, something like this, right? Which means if you take maybe nyk common, this is 2 plus 3 plus 4, just a second. If this is 2 nyk, 3 nyk, 4 nyk, yeah, till k, right? It will be till k. So if you just solve this will be k into k plus 1, something like this, k into k plus 1 by 2 or something like this. Okay, plus minus, let's not worry about it, but it will be k into k plus 1 minus 1 or something like this. Okay, and then this will be nyk. This is nyk. So k get cancel out. So finally it will be in order of nk, right? So if you are doing this kind of merging, it is order of nk. So earlier it was nlogn, but now I got order of nk. Let's call it method 2. So I hope these two methods are clear at least. Method 1, method 2. So the first method was the very naive, it was taking nlogn. Second method, I finally reduced it to nk. Why it is reduced? Because k is generally constant. I mean this could be a large number, but generally it is a constant, right? So that's why, like, let's just say that it is some improvement. Okay, great. Now let's just see that if I can further improve it something. So basically there could be different methods. Let's just see if I can further improve it to something. Let's call it method 3. Okay, so finally, see, once I do this, I will be basically telling you the summary of all the methods, but that I already have. But for now, let me just give you the ideas of the method. So in method 3, what I will do, these are nyk size, nyk size. I will say, let's just take the minimum of all. Okay, take the minimum of all, and let's just put that one element here. I will take the minimum of this, minimum of the all the first element. All the first element I will take the minimum. I will put that here. Similarly, I will put some element here after comparing all the concerned elements. So since there are k arrays, and just to put one, I am doing k comparisons. And number of elements are n, right, in this array. Since there are n elements, for each element I am doing k comparisons, so that's why the time complexity here also order of nk, right? So it is also not very good improvement. In fact, it is not an improvement from method 2, but that's okay, right? In method 3 also I am getting order of nk. Now let's just go to some other method probably, which let's just call it method 4. Okay, let me give you a hint, or it's not a hint, but let me just reveal it, that the time complexity here is going to be not nk, it is nlogk. But the idea will remain same. I mean, idea of method 3 and method 4 are same, which means in method 4 also I will be comparing all the elements, and then I will be doing it, but instead of having the time complexity k for each of these kind of comparisons, I will be just doing the log k. In the log k, I will be just finalizing this element, and since there are n elements, I will be incurring n log k. But how can I finalize this element in just log k? Let's just see this. How can I finalize this element in log k? So what I will do, I will take the first of, since there are k arrays, I will take first of each of this, and then I will put all of them in a heap. Okay, so we'll take first of all of the arrays and will put in a heap. That's what I will do, right? Since there are k arrays, it means there are k elements, right? So heap size is k. So this is your initialization. That's how you will be initializing the heap. Now at every moment I have a heap which is having these k elements. Now to get the minimum out of this heap, I will be just doing log k, right? Suppose this is minimum, so I will say that I will delete it, and whatever is the minimum, I will delete it. I mean, to get the minimum, I will be just having order of 1, but to delete the minimum, I will be having log k. So once I delete it, I will be inserting the next element here from this array. So this log k to delete min plus log k to insert the next element from here. And similarly, I will be doing it for every of the array, and then finally for each element I am just incurring log k cost. So that's why the total cost is just n log k, because for each element I am incurring log k cost. Actually, in the complete course, I have told that in, I have taken some example also, and I have told in bit detail, but here I am just making you revise this, right? Since this is theory part. Now let's just see the final method, or maybe let me just call it method 5. Let's just see this method. Here what I will do, I will be, see earlier what I was doing, I was having n by k, I was doing one kind of merging, which means I was merging these two. Then whatever I got here, I was merging this with this one. So instead of doing these things, I will be merging pairwise. So let me call it pairwise merge. Pairwise merge. So if you do pairwise merge, and let's suppose these sizes are n by k, then at one step you will be incurring cost of how much? See, these sizes n by k, if you do any merge, this will take 2n by k, this will also take 2n by k, right? I mean, the total cost will be 4n by k. and k itself is 4, so the total cost is order of n. So basically the total cost here is always order of n, because the total cost will be, you are moving like all the elements from here to here, and here you have n elements, so and you are moving all the elements here, so it is just order of n. Then you will be again doing it, and then finally you will be having one complete array, and at each level you are incurring a cost of order of n. And since there are k levels, there are k arrays, so that's why there are log k levels. At each level, cost is equal to order of n, and number of levels equal to log k. So total time is equal to n log k. So these are the 5 methods that we have already seen in the complete course also. So from there only I have taken this screenshot, right? I hope you can see this. So this is the summary of all the 5 methods that merge k sorted arrays into one. Okay, this is the summary. First one is very trivial, nlogn, which just append each of that and then sort it. Second one is successive merge. Third one, like find the minimum, put it in the array. Fourth one is also find the minimum using min heap. And fifth one is basically pairwise merge. But as you can see, out of all, very easily you can see that n log k is the best time complexity. Obviously it is better than n log n, it is better than nk, right? So that's why it is the best time complexity that you can have. So if someone asks you that if you want to merge k sorted list into one, then you can say either you use min heap to find the minimum, or you just do the pairwise sorts. Okay, pairwise sort is also a very good idea. That is also going to take n log k. Both are fine, right? This method 4 and method 5 both are fine. Now let's just solve this question. They're saying suppose there are log n sorted list, each of size this. So which means there are k equal to log n. There are k sorted list, each of size n by k. What is the time complexity of producing a sorted list of all of these elements into just one? So our answer is n log k, and here the k value is log n, so that's why our answer will be n log k value is what? Log n. So that's why it will be n log n, because this is what k is. So n log n should be the answer, which means A is the correct answer. And how do we have solved it? We have solved it either using method 4 or method 5. They are saying hint use a heap data structure, which means they are saying you can use method 4, but you can also use method 5, right? Okay, I hope you understood this particular question. For this particular, actually to solve this kind of problem, we have 5 methods, but 5 or 6 methods, I mean you may come up with 1 or 2 more methods, but that's okay, but you cannot do it in lesser than n log k. Okay. This is one problem that I would like to give you as a homework. You can just try it out. Okay, this is not a tough question. This is easy question only. Okay, so since we do not have much time, so that's why let's just stop it here, and we will do quick sort maybe 1 or 2 questions later. Okay, so in some other session we will be doing the quick sort. So I wanted to do 1 or 2 questions of quick sort, but yeah, that's okay. Like we have seen the merge sort in a good detail, that how does it even look like at every step. See, this was one of the favorite like topic to me, where I have just told you that how does it look like at every step. See, here it is looking like this, then here it is looking like this, here it is looking like this, like that, right? So now we have understood merge sort very clearly, and we have solved questions. We have seen iterative merge sort, we have seen we have also seen the normal merge sort, we have seen the third question, which is merging k list, right? So this is also very popular question, where they ask you to merge k sorted list, right? That's what we have seen at the end. See, this is very popular question, where they will ask you merging k sorted list into one sorted array. Okay, thank you everyone. Take care. Bye bye. If you have any doubt, please comment it out. If you like the session, please hit the like button so that YouTube recommend that to other people also. Okay. If you have any doubt, you just comment it out. If you want to join the Telegram group, you can join the Telegram group from here. If you want to join the test series, you can definitely join it. Right. Okay. Thank you everyone. Take care. Bye.